Happy day, YouTube. My name is John, and this is my channel, The Intermancer. At the end of the last episode, or for the entirety of the last episode, I did some live coding. As you know, I've been trying to almost vibe code, not vibe code, I hate that term, I'm not vibe coding, but I've been trying to let the LLM, Claude, I've been trying to let Claude do almost all of the coding by first focusing on describing what I wanted the code to do. But I was very disappointed with Claude's output for the evaluator. And so what I've decided to do is to code this part myself and then ask Claude to update the context file based on the code that I am generating myself. At the end of this last episode, I was dealing with a compilation error because, as it turns out, I have never had to do stream processing in Java in my professional life, and so I don't know it. I don't know it well. I'm learning. And that's one of the wonderful things you can do with these LLMs is you can ask them a lot of stupid questions. And before, everyone's been Googling for a long time. It's fine to Google a lot of things, and Stack Overflow had a lot of good examples, although Stack Overflow is kind of dead now. But the LLM is helping me learn how to use streams. The LLM, in conjunction with really learning using the IDE as a learning tool and not just a code building tool. So I was ending the last video when I was facing this compilation error because it's telling me that that any variables that I use inside of my stream, I have to be final, which means that the reference can't be changed after it's set, or the value can't be changed after it's set. That means that for primitives like Booleans, they can't be changed after they're created. But if you have an object, when you create it, you're just creating a reference to it. That reference never changes, so you can call methods on that object. So what we are going to do is we are going to create a private class, an inner class, here in the evaluator, just to maintain the state for our evaluator as we move through an evaluation cycle. I only imagine, I think I may have read somewhere, but I'm pretty sure that this whole final restriction is so that you can do parallel processing on a stream. We will never be doing parallel processing inside of a single evaluate method, so this stream will always just be running serially. So it wouldn't have hurt, but whatever. We'll go with the standard and use the code use the language the way it's intended to be used. So what I'm going to do here is I'm going to create a private class evaluation state, and it's got lead data, lead count met, all that stuff, yes, and it will have a Boolean offer prediction. The Copilot here is making a lot of suggestions, and so it's making some of these suggestions based on code that I've been doing, and some of it makes sense, but some of it doesn't make sense. So I'm just going to take it because I've really struggled to turn off Copilot inside of Visual Studio and get it to stop making these suggestions. So I'm just going to take this one and then make sure that I read through and understand everything it's doing. So offer prediction, double prediction, it takes that lead data dot offer prediction if bang lead count met. Now this weird construct here, it took from my code below, and the reason I'm doing it this way is because I'm really trying to minimize all unnecessary comparisons in the code as much as possible, because I expect to be running this evaluator quite a bit on any test run. So it behooves me to make it as efficient as possible. So if the lead count is not met, then we implement lead count, and we say if lead count is greater than or equal to get lead consumption count, then, so we're doing this comparison every time until it's met. So lead count met is true, return true. Actually, we can say this, boom, boom. Lead count met. Okay, so if it's not, then we do all this and then we do that. Okay. So I can say here, get rid of all this stuff. Evaluation state, new, that's right. So don't need this. If state dot offer prediction. So if it's ready to do a comparison, okay, if it's not ready to do a comparison, return 0. No. Then current prediction. Don't need to do anything because current prediction is already set to 0 on. And so current prediction equals state dot get prediction. We will create that method. Don't need to add that. Double get prediction. We don't need to throw anything. So I don't need to do this check here because I can assume that there's at least one. So return lead data dot poll. Okay. Actual value, current prediction. Let's change this to future prediction. Future prediction, current prediction, quantum, actual current prediction minus actual value, future prediction, and sum. Okay, that's all we want to do for that. I notice right over here, I've got another compilation error here. Yeah, this is named incorrectly. Okay, so one thing I know I want to do, because I've been thinking about this, is I want, for testing purposes, I'm going to give myself a way to just set historical data. So we'll say public void set historical data. That's all good. We'll say that this is for training purposes. I don't know why I did this. Sets the useful for testing. Okay. That's that. I think that's everything I need here. Real quick, let's see if there are any problems. Lead data can be final. Go ahead and do that. I don't need it to be final, but I'm really trying to make my code work seamlessly with the IDE, because I assume that most of these warnings and these bits of advice are coming from some source outside of the IDE. So if it works smoothly with this IDE and doesn't provide any warnings, and it's probably not going to give me any warnings for other IDEs, like when I move over to IntelliJ. So we'll say final here. That goes away, save that. Now this basic evaluator test that I had before, test full evaluation cycle. This is not testing the correctness. Test ensure. This test checks that the default training data is loaded correctly and that the evaluation process works does not throw any exceptions. That's really what I'm doing here. Okay, save that. Now let's see if this runs. Build successful. Everything's fine. Now this test runs with the training data, but it doesn't actually make sure that the evaluator is working correctly. So what I'm going to do is do another hand test here. Public void test evaluation logic happy path evaluation logic happy path evaluation. Okay, basic organism, new chromosome, outer one, organism. Okay, look, anytime you have code that you're repeating like this, it's best to extract it. So let's go ahead and do that real quick. Refactor. Modify, move, change, surround with. Okay, it's not giving me an easy way to do that, so we'll just say this and have a private organism create test outer organism. Wow, it's actually kind of smart. Look at all this stuff it did here. That's exactly what I wanted it to do. So now we'll say organism equals that. Same for this. Test genes.get test data. Where is it? What? So look, this is just a straight up hallucination. Test genes.get test data. Where'd this come from? That doesn't exist. I'm going to create historical data here, and I'm going to be pretty straightforward with this. I'm not going to have open, high, low, close, and all of that stuff. I'm just going to create a couple of numbers and we'll do 5 numbers. We'll set the predictive cycle to 2, and we'll see how that all works. So list data quantum, don't want that, new array list, import data quantum, import array list, okay, historical data dot add new data quantum. What's that constructor? Data quantum doesn't have that weird constructor, does it? Let's see. Another hallucination, just all kinds of weird hallucinations. Data quantum, just set data points. Yeah, I don't, what's the structure on this? Data quantum. So it's got that one constructor. Why does it hallucinates so much? I don't know if you saw, there was a bunch of weird stuff it was adding as far as having a constructor for data quantum that took a date and then a list and all that. So we're not doing that. Dot add data point. New data point. So what's data quantum dot data point? Data point is inside of here, right? Yeah. Data point. Can send it, okay. It's got either no arg or this one that takes its source ID and a value. All right, I'm gonna go ahead and add a constructor here that just takes a value, just for making tests easier. So public data point double value. There, that'll work. Let's add a test or a comment. That's good. That's what it's doing. Take all that. New data point 1.0. Have too many here. That goes with that. That goes with that. That goes with that. I got too many. Void type not allowed here. What's a void type? New data point. Add data. What? What void? Historical data. List of data quantum dot add new data quantum. Let's add extra parentheses. When in doubt, add parentheses. Void type not allowed here. Add data quantum. Okay, whatever. Why is it saying void? Let's ask Claude. I am writing this in a Java test class. The compiler is saying that there is an error. I don't understand that error since, let's go ahead and remove these extra. Oh, because add data point returns no. Got it. Understand as I was typing it. So what's happening is this add data point method returns null. So it wasn't letting me add it. So we will in data quantum add data point. We will say that add data point returns data quantum return this. Okay. That should work there. That should get rid of that. Okay. Well, yeah, that's weird. I don't know why it came up with that. Okay, so I don't need these parentheses now, do I? Okay. And we will do 5 of these. 5, okay. Score equals Evaluator. There we go. Evaluator dot set. What is, so it's got this default, okay, historical count. Where's the target index? That's used, but it's never set. Okay, so we are going to say, by default, it goes to 1. And since it's pulling out of, okay, that should be fine. Since this only has 1, 1 will loop around, that should be fine. But I do need, because it's a final. Do I have set target index? Go ahead and add that. Public. Does this have just do code? Can I just do create getters and setters or something? So this is one of those things that people complain about Java with all its verbosity. And I could use Lombok, which is a nice framework that makes it to where you don't need all the getters and setters. You can just annotate things and it creates that for you, but it's not basic coding. And I'm trying to get this as basic and straightforward as possible. And that's, even though it's verbose, one of the advantages, I think, in Java is that it makes everything right there with no, by default, no hidden stuff. I mean, obviously, if you start using Spring, there's a whole lot of black magic that goes on there. But by default, out of the box, Java doesn't have a lot of black magic. So here, I'm just going to say public void set target index. I don't need to worry about if it's negative, since my data quantum can handle whatever. Public int get target index. Why is it saying there's an error there? Public void set lead consumption count. Same thing. Okay, no, it does need to be greater than 1 or greater than 0. Oh, I've already got it. Get target index. Oh. Get lead, set lead consumption count. Do I have get lead consumption count? Get target index. Get lead consumption. Set target index. Okay, I think I'm good there. Set. We'll set that to 2. Okay, so now it will evaluate it. So it does 1 and 2, and for each of those it adds 1. So assert true score, assert equals score assertions. Oh, yeah, static import. This is going to fail the first time I run it. Let's just go ahead and run it and we'll see what it gets. And then I'll update the test so that in the future it expects what I get here. Okay, test 1 failed. Test results. Okay, that's interesting. Oh, Okay, so it gave that. But it doesn't tell me what it. Okay, let's just get rid of this message. And then rerun it. Test results. Expected 6, but was 0. Okay, so let's get that in the right order then. 6.0 score. There. Okay. All right. So now let's do the build. Let's see if the build passes. If the build passed, then I think it's good. I think it's pretty much good. We got no problems. I've got a test. The test ran. So 6, let's see, this adder is adding 1 every time it goes through. And so the first time it goes through, this gives it the second one is 2. So it compares 2 to 3. Huh. I want to go ahead and watch it do its evaluation. I want to watch this happen. Okay, basic evaluator test. Let's go ahead and watch this thing run. Debug test. Since this is a small test, I can afford to just watch the cycle and keep track in my head of everything that's going on here. Okay. So organism consume data quantum. Data quantum is got a data point of value 1. It's good. Future prediction here. 2, what do we expect? Current prediction is 0. So if offer prediction, it offers that, and this should return false. Okay, good. Actual value, this should return 1. 2. Oh. That's why I had a different one than what I expected. Okay, here's the problem. I said the target index to 1 when really the target index should be 0. Because what it's doing is it's looking at the data point that came as a result of evaluation. So let's just go ahead and play this through. Play. Okay. So for this, we're going to say, and this is going to make it fail again. Evaluator, set target index 0. There we go. Wow, it just took that by default. All right, let's go ahead and run this. We'll see it fail. It'll tell us what value it expected versus what it got. I thought that was a little high. That's kind of why I wanted to run through it. Expected 6, but was 1? 1? All right, so let's go ahead and debug that. I don't expect 1. That doesn't make sense to me. Okay, we don't need this. Pain. All right, so stepping through here, we would expect the same thing. Future prediction 2, current prediction 0, right? Right. Actual value. And current prediction is 0. Actual value is 1. That's 1. Okay. Actual value is 2. Current prediction. Oh. Since I'm only doing 1 and it grew by 1, it's actually, but it went 2. So on the second one, it went. Okay. I want this to be a little bit more interesting. So we will say, we'll add a couple more here. So we'll say 6, 7, lead count is 3, target index is that. Save this. So on this one, that looks good, honestly. So I'm just going to go ahead and correct this, but then I'm going to debug it. Debug test. Let's see what happens here. Don't want that panel, that pane. So for the first one, it comes through no. What is going on here? Okay, apparently it played through because it was in the middle of running, so it started the test. It's going to play through to where it's done. Stop it. We'll just stop it. Okay, I think the IDE, I changed the code while the previous test was still running. That's why it was spinning there. So let's go ahead and run it to see if it passes. Passes, but now we'll go ahead and debug it to watch it work. Close this pane. Step through, no, okay. Current prediction, okay. This one should also skip over. Actual value is 2. Okay. Go through that. Now this one, it should go in there and get the current prediction. Good. 2. And this is, which data quantum are we on the third one, right? Yes, third data quantum. So since I've got 7 of these, 3, 4, 5, 6, 7, 10. Why doesn't it give me 10? That's interesting. That is interesting. Actual value. Don't need that. I don't have any watches. Current predictions, that's 1. Okay. Because the first 2 had that, so it's just adding 1 here. Okay. Go ahead and add a breakpoint here. Value 4. Current prediction, actual value is 1. So 1 for the first data point and the second data point. And how many data points are there? Went to 7. So 8. That's where it gets 8. 8. We're good. We're good. We're good. Okay. I am happy with my test. I'm happy with my code. Let's go ahead and push everything up. This has been 42 minutes. Going to go ahead and call it here. Basic evaluator works as expected according to the happy path testing that I've done so far. We might see errors later. I'm not going to close out the branch because I still want to get the context to match what it's seeing here. But there we go. We'll do the context thing next time. That'll probably be a very short video. Thank you for your time.